This is section 5.4, which is on the indefinite and definite integral. So it's not really a new section. We're rehashing the concept of an indefinite integral from section 4.9, and we're doing definite integrals using the fundamental theorem of calculus from 5.3. Okay, so the homework was 5 to 43 odd, 49, 59, and 61. Let me go ahead and show those to you. So on page 408, so you notice these problems are indefinite integrals. They do not give me a number on the funny looking S. So your final answer is going to be blah, blah, blah plus C in general, just like it was for section 4.9. And then starting with 21, it looks like we have definite integrals. You see numbers there, which means your final answer doesn't need a plus C. Your final answer is going to be a real number. You're going to be plugging in the upper limit, plugging in the lower limit, and then subtracting. Okay. 49 is rather unusual, but 49, it's really just X as a function of Y. You'll be doing a lot of that in Calc 2. And then 59 and 61, I think it was. 59 and 61. Concept between 59 and 61. The acceleration was the second derivative. Velocity is the first derivative. So there were some problems before where we took a distance function, we differentiated, we got velocity. Take the second derivative, we got acceleration. Now we may be going backwards, starting with the acceleration or velocity and integrating to go back to the original function. Okay. So we'll be jumping around quite a bit here. Okay, so number 5, integral of x to the 1.3 plus 7x to the 2.5 dx. This is an indefinite integral, so your answer is going to be blah, blah, blah plus c. Use the power rule, x to the 2.3 over 2.3 plus 7x to the 3.5 over 3.5. 7 divided by 3.5 is 2. So final answer, x to the 2.3 over 2.3 plus 2x to the 3.5 plus c. Number 9, notice the notation, it's u du, x dx, w dw, or whatever. Now, there is no product root for integrals, nor is there a quotient root, so the only thing to do is multiply it out. So if you multiply it all out, you get that. Then you do the power root. 2u cubed over 3 plus 9u squared over 2 plus 4u plus c. Okay, now 21 is a definite integral. There are definite numbers here. So your answer doesn't have a plus c. In fact, your final answer is going to be a real number. So we still integrate x cubed over 3 minus 3x. Okay, the funny looking s moves over to the right side and plug in 3, plug in -2, and subtract. That's what we had from the fundamental theorem of calculus part 2 last time. Plug in 3, I get 27 over 3, which is 9, minus 9, that's 0, that crosses out. Minus, plug in -2, -8/3 plus 6. So that's 8/3 minus 6, -10/3. An integral can come out to be -10/3. So that means that there's more graph below the x-axis than above the x-axis in this particular case. 27 is also a definite integral. There are definite numbers. So again, the answer is a real number. So we integrate. Integral of 5 e to the x is itself. Integral of 3 sine x is -3 cosine x from 0 to pi. Plug in pi. 5 e to the pi minus 3 cosine pi. Cosine pi happens to be -1. Minus, plug in 0, 5 e to the 0, which is 1. So 5 minus 3 cosine of 0, which is 1. So I have 5 e to the pi minus 3 times -1 is plus 3, minus 5 plus 3, 5 e to the pi plus 1. Okay, so you're still integrating. If you have an indefinite integral, the answer is blah, blah, blah plus c. If you have a definite integral, you still integrate. You don't need a plus c. Plug in the upper number, plug in the lower number, and then subtract. Okay. And by the way, just to go back to one previous type of problem, 5.361, let me just finish that one up. This was fundamental theorem of calculus part 1. Find the derivative of this function. There are 2 variable expressions. So we split this up, and instead of going from x to x squared, we say go from x to 0 and 0 to x squared. This is okay. It's constant on the bottom, variable expression on the top. These are backwards, so you flip it and put a minus sign. So negative integral from 0 to x. plus the integral from 0 to x squared. So f prime is negative of, just put x right there, e to the x squared. And for this one, put x squared there, but because of the chain rule, it's times the derivative of x squared, which is 2x. So negative e to the x squared plus 2x e to the x to the fourth. Okay. 23 is a definite integral because there are definite numbers here. So integrate power root 1/2 t to the fifth over 5 plus 1/4 t to the 4 over 4 minus t squared over 2. Don't need the plus c from -2 to 0. Okay, clean this up a little. I get this. Okay, plug in 0, you get all zeros. Minus plug in -2. That's -32 over 10. And -2 to the fourth is 16. 16 over 16 is 1. -2 here gives me 4. -1/2 times 4 is -2. So it's positive 32 over 10 minus 1 plus 2. 16 over 5 plus 1, 21 over 5. 29. There's no quotient root, so we just have to divide through. We call that square root of u means u to the half. So that gives me 4u to the negative half plus 6u to the positive half. That's u to the 1 divided by u to the half. Okay, so I integrate 4u to the half divided by half means times 2 plus 6 u to the 3 halves divided by 3 halves means times 2/3 from 1 to 4. That's 8 radical u. 6 times 2/3 is 4. U to the 3 halves from 1 to 4. Plug in 4. 8 radical 4 plus 4 times 4 to the 3 halves minus 8 radical 1 plus 4 times 1 to the 3 halves. Well, 1 to anything is 1. So square root of 4 is 2. 8 times 2 is 16. 4 to the 3 halves means square root of 4, which is 2. 2 cubed is 8. 8 times 4 is 32. Minus 8 times 1 is 8. And that's 4. So 48 minus 12, 36. Okay, 49, it's not really any harder. It's just to show you that you could have x as a function of y. It only looks weird because we're not used to it. Okay, this x equals 2y minus y squared. So I'm integrating as y goes from 0 to 2 of the function x equals 2y minus y squared. So instead of y as a function of x, we have x as a function of y. In fact, if you turn the book 90 degrees, then that looks like, oh yeah, that's something that I'm recognized. And so I just integrate the area, quote unquote, under the curve. But if it's like this, it's to the right, to the left of the curve bounded by the y-axis. Okay, other than that, it's the same as before. So you integrate from 0 to 2y of 2y minus y squared dy. You do want to get somewhat comfortable with this because you are going to get some of these kinds of problems, especially in Calc 2. You have a few more x as a function of y problems. So anyway, 2y squared over 2 is y squared minus y cubed over 3. So plug in 2, 4 minus 8/3. Plug in 0, 0 minus 0. So 12/3 minus 8/3, 4/3. Okay. And I wanted to go back to 11. I'm jumping back and forth so you can recognize definite versus indefinite integral. So 5.411 is an indefinite integral, which means the answer is blah, blah, blah plus c. Okay, so 1 plus x to the 1/2, square root of x, plus x divided by x to the 1. No quotient root, just divide. So 1 over x, x to the half divided by x to the 1 is x to the negative half, and x divided by x is 1. Okay, so ln absolute x plus x to the 1/2 divided by 1/2 means times 2 plus x plus c. Change that to radical x. So ln absolute value of x plus 2 radical x plus x plus c. 13 is also an indefinite integral. The integral of sinh is negative cosine of x. Integral of sine is negative cosine, but the integral of sinh is cos plus c. So that's it. 15, the trick for this one is to rewrite 2 plus tangent squared as 1 plus 1 tangent squared, because 1 plus tangent squared is secant squared theta, d theta. All right, integral of 1 d theta is theta. Integral of secant squared is tangent theta plus c. Okay, 17, again, there's no product rule, but distribute. 2 to the t times 1 is 2 to the t. 2 to the t times 5 to the t is 10 to the t. All right, so 2 to the t over ln2. You might recall the derivative of 2 to the t was 2 to the t times ln2. So you multiply it by ln2. So when you integrate, you do the opposite. You divide by ln2. And likewise, integral of 10 to the t is 10 to the t divided by ln10. plus c. By the way, I double check. What's the derivative of this? Derivative of this is the same thing times ln 2. ln 2 cancels out. Derivative of this is same thing times ln 10. ln 10 cancels out, so you get that back. Okay, 25, notice it's now a definite integral. So your answer isn't going to be plus c. You plug in 2 and you plug in 0. And there's no product. We just multiply it out, FOIL it out. 8x cubed minus 12x squared plus 2x minus 3. Okay, so 8x to the 4th over 4 minus 12x cubed over 3 plus 2x squared over 2 x squared minus 3x. Don't need the plus c from 0 to 2. Plug in 0, you're going to get 0. So plug in 2. That's going to be, clean this up a little bit. 2 to the 4th is 16 times 2 minus 4 times 8. That's 32. These cancel out. 2 squared is 4 minus 6. So the answer is negative 2. Yes, an integral can come out to be a negative quantity. That means there's more area under the x-axis than above. 31, definite integral. This is x to the 3rd, x to the 4th. So if I distribute, x times x to the 3rd is x to the 4/3. X times x to the 1/4 is x to the 5/4. Okay, so power root x to the 7/3 divided by 7/3 means times 3/7. X to the 9/4 divided by 9/4 means times 4/9. Plug in 0, you get 0. Very nice. Plug in 1, 3/7 plus 4/9. Do the arithmetic, 55 over 63. 33, x over 2 minus 2 over x. Treat this as half x minus 2 times 1 over x. So that's going to be 1/2 x squared over 2 minus 2 ln absolute value of x. Plug in 2. I have, by the way, cleaning up, x squared over 4 plus 2 ln absolute value of x from 1 to 2. Plug in 2. 4 over 4 is 1 minus 2 ln absolute value of 2 is 2 minus plug in 1, 1/4 minus 2 ln absolute value of 1 is 1, but ln 1 is 0. That's gone. So I have 1 minus 1/4, which is 3/4 minus 2 natural log of 2. Okay, 37. Divide through. 1 divided by cosine squared is secant squared. Cosine squared divided by cosine squared is 1. Okay, so integral of secant squared is tangent. Integral of 1 is theta from 0 to pi over 4. By the way, the tangent of 0 is 0 plus 0. So this is when I plug in 0, I get 0. Pi over 4, tangent pi over 4 plus pi over 4. Tangent of pi over 4 is 1. So 1 plus pi over 4 is my answer. Okay, finally 59. Okay, so those problems at the very end. '59, v of t is 3t minus 5. T is between 0 and 3. Find the displacement and the distance traveled by the particle during a given time. Okay, displacement and distance. So distance is the amount that you actually walk. Displacement is how far you are from your beginning spot overall. Okay, so an example is if I walk to the left 5 feet and then I walk to the right 5 feet, the distance that I've traveled is 10 feet, but my displacement is 0. I end up exactly where I left, but I got some exercise. I walk 5 feet one way and 5 feet back. So that's the distance traveled. Okay, so what I'm going to analyze this is in terms of the area. So 3t minus 5, we know it's linear. It looks something like this. If I plug in 0, I get -5. Okay, it touches the t-axis, x-axis equivalent at 5/3, right? What makes that 0? 5/3. And when I plug in 3, I get 4. So at first, a negative velocity means I'm going to the left. Positive velocity means I'm going to the right. So I'm going to the left up until 5/3. Okay, and then I turn around and go the other way. Right? So if I want the total distance that I traveled, I count both of these areas as positive. If I want the displacement, the negative part would be this area, and the positive part will be this area. Okay. So again, displacement, positive area minus the negative part of the area. For the total distance, you simply add both areas. Okay, so I'll leave that to you to figure out how to do that, but you can find this area 1/2 base times height. This area is 1/2 base times height. Okay, add the two areas for the displacement. Take the difference of this two, so whatever this minus this is will be the distance. We'll take the absolute value of that. Sorry, that would be for the distance. The displacement, yeah, the total displacement, sorry. It's this thing minus this thing as an area. Okay, so you figure out 1/2 base times height, 1/2 base times height for that one. Okay. Finally, for 5.461, to give the acceleration function, and v of 0 is 5, and you're going from 0 to 10. So find the velocity and then the total distance traveled during a given time. Okay, so to find the velocity, I integrate from t to 4, t squared over 2 plus 4t plus c. But now I can find the c because v of 0 was given to be 5. So the answer is 5 if I put 0 here and 0 here. This is like section 1. So c is 5. So the velocity function is 1/2 t squared plus 4t plus 5. And now from that, if I want the total distance, I integrate, they told me to go from 0 to 10. So I integrate from 0 to 10 of 1/2 t squared plus 4t plus 5. So it's 1/2 t cubed over 3 plus 4t squared over 2 plus 5t from 0 to 10. Clean it up, t cubed over 6 plus 2t squared plus 5t from 0 to 10. Plug in 0, you get 0. Plug in 10. 10 cubed is 1,000 over 6 plus 2 times 100 plus 50. Work it all out. 1250 divided by 3 meters, or 416.6 repeating meters. Right, so that was section 5.4.